Hello everyone. Today I'm going to talk about hypothesis testing. As I explained about the steps of statistics before, the most important step was data analysis. So in order to be able to report our conclusions, we need such testing. And now let's go through hypothesis testing in detail. So hypothesis H null or H0, and the alternative HA, and in some books they show it by H1, are two mutually exclusive statements about some unknown parameter theta. So we will talk about it in details, that what is H0, what is HA. And we should know about the steps of hypothesis testing. So first thing to do is to get a sample from our population in order to estimate this unknown parameter from that population. So we need to take a sample, and by collecting data, it means that we take a sample with a specific size, let's say, for example, lowercase n, and then by using that sample, we will predict the value for theta. So since we are estimating that, we call it theta hat in that case. And this is a point estimator, and we said also it is possible to use confidence intervals. So first step is to collect the data. It means that to take a sample. The next step is to compute a test statistic. We will talk about it in details, and for computing it, we should know about the differences between the cases, which I will talk in details. So state if there is sufficient evidence to reject H0 in favor of HA. So we should talk about these two terms in details. So what we are doing in hypothesis testing is to check which one of these two is correct. H0, which is our assumption, and HA is the complement of that. So you see here, these two should be mutually exclusive. So for example, here you see H0 is mu is equal to a value. H0 here is just an assumption, and this is a value. So for example, mu is equal to 30. This could be my assumption. So what we are trying to do in this test, shall we accept that mu is equal to 30? It means that we estimate it and we say with certain confidence level that this is the case or not. And if we are able to reject it at certain confidence level, then we accept this one. So whenever you accept HA, you say we reject H0 with, for example, 1 minus alpha confidence level. So we will talk about them in details. So what we are trying to do here is that we have H0 and HA, and we should finally accept one of them. Usually we say accept or reject H0, and whenever we say rejecting H0, it means that accepting HA. So it could be equality here, and we have not equal case for HA, and usually consider not equality for HA, not H0, and I will explain why. And for mu less than mu 0, we can have such a case, and then for HA, we should have the complement of that. So whenever it has equality here, this part shouldn't have equality, okay? So we should be careful about that. So more than that, and mu 0 is just a value, be careful. This is just a value like this. So this can be H0, and HA could be mu. So this one doesn't have equality, this one should have equality to be exactly complement of each other. In some books that you can observe that this is not always the case, but let's say for our course we want to do that, to have such a strict rules in order to make no mistakes. And if you apply this method, you can cover all possible hypothesis testing, and there won't be any problem with that. So be careful that these two H0 and HA should be mutually exclusive. It means that there should be no intersection between them, and you should define them like this. And not equal case, always consider it for HA, not H0, and I will explain why. So whenever you run such tests, you will have errors sometimes, because you see we are taking a sample from the population. So if you find mu hat, which we showed it by X bar, for example, let me show it why it happens. Let me show it here, X bar, mu hat. So this one is the estimator of mu, right? Mu is the parameter of the population. So when you take a sample and you will find mu hat or X bar, then in that case, it's not necessarily equal to the reality, right? And whenever you define a confidence interval, not necessarily a parameter of the population will be included in this interval. So sometimes we have error. So what types of error can we have? So assume that in reality, H0 is true, but we reject it by mistake. So here we had a mistake, and this one we call it type 1 error. And type 1 error, you can denote it by alpha. Okay, so we call it also significance level. And type 2 error is the case that H0 is actually false, but we accept H0 by mistake, and we show it by beta. So in case H0 is false and we rejected that, we were correct. So we didn't actually have any error. So it can happen. So when it happens, like we have, for example, such errors, and we know that, we say, I'm sure about my test 1 minus alpha. Why is that? It means that alpha is a probability. So the values that you can have for alpha, it should be between 0 to 1. So, for example, if alpha is 5%, it means that you are sure about your test for 95% confidence. And we will talk about it in examples much better. But as I mentioned, we should be careful that alpha is actually a probability. You reject H0 when H0 was actually true. We made a mistake. So do you remember this conditional probability? Such that, so we know that this part is true. Now, what's the probability of rejecting H0? This is exactly what we have shown here for type 1 error. And if you find the probability for the case that HA is true, actually, when you reject H0, then we call it the power of the test. So in our class, we are focusing on alpha, because if you know about this, then beta also very easy to calculate. So as we said, the first step of our hypothesis testing was related to getting the sample from the population. But the next step is to calculate test statistic, okay? Test statistic, and this is a new term that we are using here. So we should know how to calculate test statistic, and each one of the cases have its corresponding formula. So how to do that? For confidence interval, I already mentioned you about the cases. But anyway, for test statistic, I've decided to create all the cases so that it will make it easier for you guys to know how to calculate test statistic. So let's go through all the possibilities. So sometimes we are just interested to estimate the mean of the population. That's it. So there is a population, you get a sample from it, and the parameter of population is mu, and we are looking for this one. So we want to estimate it by mu hat or X bar. They are equal. So when can we use this formula? z0 is equal to x bar minus mu 0. Mu 0 is always given to you when you construct h0 and ha. So if you decide, for example, in your, for example, h0 and ha, mu 0 is equal to 30, then you just assign it inside this formula. So all of this information should be given. If you don't have, maybe this is not the correct formula. So here, for example, you see, mu 0 should be given to you. That's how you run the test. And in this example, I say, for example, you can consider it 30. We will practice it in the tutorial to see how we can assign. So here I explained what is mu 0, so later you can again check. And when is this test statistic useful? The population is normally distributed. So here I know that the population that I took sample from, this population is normally distributed. The value of the variance of the population is known. It means that I don't have information about mu because this is the one that we are trying to estimate. But I have information about the variance. So two conditions. Population is normal distributed and the variance of the population is known. Because in the formula I want to use it here. Here is the standard deviation, so I should take the square root of that in order to assign it to this one. So that's the case that you should use it. So I'm going to show you all possible test statistics. We go through all the cases and we will practice with some of them just to know how we can do it. But if you know one of them, it's good enough to solve the rest because now you know about the conditions. The only thing left to do is just using the formula and then the next step, which I will talk about after test statistics. Okay, another z-test that we can use. Why do I call it z-test? Because it is corresponding to a standard normal distribution. For the previous one, it was the same story, and I will talk about it later in details why. So sometimes it's possible for me to use CLT. Do you remember what is CLT? Central limit theorem. When can I use it? When sample size is big enough. So when you take a sample from your population and your sample size is big enough, and in our course, we consider more than 30 big enough, and this is not always true for different projects, but in our course, for our exams, consider 30 big enough for the sample size, okay? So even 29 won't be a big enough size for the sample size, okay? So when can I use this formula? What is different between this formula and the previous one? Here I have S instead of sigma, you see? Why is that? Because I don't have information about the variance. So the sample size is big enough and the value of the variance of population is unknown. If it was known, it was the previous case, okay? So I had this information and I knew that the population is normally distributed and I could use it. But here, I didn't mention anything about the population distribution. Why is that? So if it is normal distributed or not, doesn't matter because of central limit theorem. So remind yourself about this important theorem. That's the beauty of this theorem. As long as the sample size is big enough, then you can approximate everything using z-score. Perfect. So that's the second case that I wanted to talk about related to z-test using CLT. Although the population variance was unknown, still there was a way for me to use z-test. But what about t-test? It means that we are using t-student distribution, not standard normal distribution like previous slides. In this case, you see, this is exactly the same as the previous formula. You see? But the thing is that here I write T0 instead of Z0 because at the end I want to compare it with T distribution, okay? And I will show you later in the next step why this is important. Because you exactly receive the same test statistic as the value. But when you compare it to the distribution, maybe you reject and accept H0 at different levels. Okay. So when we can use this test statistic, we should have these conditions. The sample size is not big enough, you see? This is not big enough. So you have a population, the sample size is not big enough. So I cannot use central limit theorem. The value of the variance of population is unknown. Okay, I don't even know if it is normally distributed or not. Okay, so far we had two problems. The sample size was not big enough and it was not, the variance of population was not known. So what can I do here? The population is normally, the population is normally distributed. So we know that the population is normally distributed, but we don't know about the variance information. Okay, so let me again rephrase it from the beginning since I didn't explain it correctly. So there are three conditions. The sample size is not big enough. I know the population is normal distributed, so I know about this, but I don't have information about the variance of the population. So if the variance of the population was known, without even considering the sample size, I could use the first test statistic. You see, normal distributed variance is known. But here, it is normally distributed. The variance is unknown, and at the same time, I cannot even use central limit theorem. So that's why we can estimate the parameter using this test statistic, using the t-student distribution and have a t-score instead of z-score. Okay, next one. What if the sample size is not big enough? Even 29 we said is not big enough, but if it is exactly 30, consider it big enough. Okay, so the value of the variance of population is unknown. The distribution of the population is also unknown. I don't know whether the population is normal distributed or not. And at the same time, I don't have any information about the variance of the population. Okay, this one is unknown. So we have too many problems now. I don't know about the population distribution, because if I knew, just compare this one with the previous one. You see, they are very similar. The only difference is that this one has a population which is normal distributed, this one not. And so if I had this information that the population distribution was normal distribution, then in that case, I could use t distribution. But here, I don't know about the population distribution. So the value of the variance of population is unknown. If it was known, then I could use the first case. The sample size is not big enough. If it was, I could use CLT. So because we have too many problems here, the only way to solve it is using non-parametric methods. Non-parametric methods are very useful when you don't have any idea about your population distribution. And also, it is not possible for us to take large samples, because if you don't know about your population distribution, if your sample size is big enough, then you can approximate everything by a standard normal distribution. So non-parametric methods are very useful, but this is out of the scope of this course. That's why we are not going to solve examples about this. But in the exam, if such a case happens, like you cannot solve it with either three other conditions, then please just mention that we should use non-parametric methods because of these reasons, and that's the final answer, okay? But for other cases, you know, for these three, you should know, and we will also practice it in tutorial. All right, what if we want to estimate the difference between means of two populations? For example, let's say we have two populations. I want to check whether these mean of these two populations are equal or not. So if I consider this one H0, HA will be not equal, right? And I can also show it like this. That's why it is called the difference between two population means. And not always this part is 0. Sometimes I want to check, for example, whether the difference is equal to, for example, 2 or not. This one, I can call it D. So we denote it by D, as I also mentioned here. So you see in this example, D is equal to 10. And it's not always equality, be careful. Sometimes it could be more than, less than, and so on. Okay, now in case that both populations are normally distributed. So now we are dealing with two populations now. One of them has parameter mu1, the other one mu2. We take samples from each of them. First one, x bar 1, second one, x bar 2. And that's why you can see such things in the formula, okay? X bar 1 minus x bar 2. So when we say sigma 1 power 2, it means that variance of the first population, we are talking about this one, okay? So these indices are important. What is N1 and N2? Sample size for the first sample here, sample size for the second one. You see? So about the conditions. When both of the populations are normally distributed, fortunately I know that. So the values of the variances of both populations are known. Good. Now I know about these two. Great. When this is the case, then I can use them inside this formula, as you can see, for variances of both populations. So this is the way I can use z-test. And as you can see, we are talking about difference between means. So that's why I denote them by section number 2. The previous ones, I denoted them by section number 1. Okay, just estimating the mean of the population. Now we are talking about the difference between mean of two populations. Okay, case 2. In this case, the sample sizes are big enough. When this is the case, I don't even care about the population distributions because I can use CLT. Good. The values of the variances of both populations are unknown, because if they were known, I could use the previous one. So instead of using sigmas, as you can see, I can use variances of the samples. You see, I take sample from each one of them. So this one, S12, S22. Okay, so in the previous scenario, if I know that what is sigma 1 and sigma 2, and I have sample, and easily I could find what is, for example, S12, I shouldn't use this one in the first case, because I already have sigma 1 and sigma 2, which is perfect, that we know that. But in case that we don't know that and sample sizes are big enough, then I can use CLT, and I should calculate S12 and S22 so that I can use z-test. And you will find z-score for that, which here we call it test statistic. And be careful about this part. It should be at the same time. It means that if, for example, N1 is equal to 10 and N2 is 40, so this sample size is big enough, but this one is not. So we cannot use this case, okay? So both of them should be big enough. What about t-test? for two populations. So when we can use that. So the sample sizes are not big enough. Either one of them is not big enough or two of them at the same time. The values of the variances of both populations are unknown. Okay, another problem here. But fortunately, I know that both populations are normally distributed. This is very important to be able to use t-distribution. And also, I have this information that the variances of the populations are equal. Interestingly, I don't know what are their values, but I know that they are equal. So, two populations, and we have sigma 1 for this one, sigma 2 for this one. And I know that they are equal, but I didn't know that, for example, what are the values of them. So I still don't know. That's why we say variances of both populations are unknown, but I know at least they are equal. When it happens, usually such case happens when actually these two populations were derived from the same population. It's like first you have just one population like this, then you try to partition your population. So when you partition your population, sometimes it happens. Like, for example, let's say I partition the whole university in terms of being male or female. Since both of them are coming from the same population, sometimes it happens that we can have such assumptions, okay? Not necessarily related to my example, just I wanted to let you know that why such cases happens. That we don't know about the values of sigma 1 and sigma 2, but we know that they are equal. That's the reason, because they are derived from the same population. So their nature is basically the same, but their mean can be different, like the height of students. So the height of students, the variance could be exactly the same, but for example, mean of them for male and female could be totally different. Okay, so what we should do here, in this case, I should use this test statistic. And for this part, I should use pooled variance. So I should calculate this one. So for the formula related to that, we will practice it in the tutorial so that I can show you how you can use S2P. So this one is related to S1 and S2, but we should calculate it based on them and the degree of freedom, which I will talk about it in the tutorial. So for these parts, I explained already what is D, you know, X bar 1, X bar 2, and the sample size. So when to use this one? When we have these three conditions. But what if I don't know that these two variances are equal, or in fact, I consider them not to be equal? In this case, I should use the approximation of t distribution. For this one, I'm not going to ask it in the exam to provide me the complete solution. But if we ask such a question in the exam, you should say we should use the approximation of t-test, t-distribution, and mention that because this is the reason. We have these three conditions, and here actually four conditions. And because of that, I should use the approximation of t-distribution. So t-prime test, you can call it. And that would be the final answer. But for the last three cases, we need the complete solutions. So far, I told you about two steps. I should also explain about the third step so that we will complete our hypothesis testing. Anyway, the last case which can happen for two populations. So for this one, this is very similar to the previous slide, but there is a big difference. Distributions of populations are unknown. So As you can see here, the sample sizes are not big enough. Both population variances are unknown. And at the same time, the distribution of populations are unknown. If it was known, I mean, it was, for example, normal distributed for both populations, I could use case 3, case 4. But I don't know about the distribution of those populations. So I have no other choice to use non-parametric method. And the reason is very similar to the one that I explained for one population. So again, if I ask you a question about non-parametric method, you say for these 3 reasons, we should use non-parametric methods, and that's the final answer. But for 2.1, 2.2, 2.3, we need complete solution, and we will practice it together in tutorial. Okay, so we have different types of alternatives. We should be careful about the third step of hypothesis testing. So when I say T here, it means that the test statistic, I mean that. Otherwise, you can also, if you use z-test, then we show it usually by z0, as you know. Okay, here you can see we have shown acceptance regions and rejection regions. So here, if I say I want to run a test with 1 minus alpha confidence or alpha significant level, for example, I want to run a test with 95% confidence level. It means that 1 minus alpha, right? It means that alpha is actually 5% based on what I just said. So in this case, you should be able to find Z alpha. What do I mean by Z alpha? It means that you should be able to find Z 5%. If it is on the right side and we are talking about 95%, then you should be able to find this one. So that's the way I find the value of this Z alpha. So when I say Z alpha, it means that I'm talking about this. But how can I understand I should check for the right side or the left side or both sides? You see, there are different cases that can happen. Please be careful and pay attention to this part. So it really depends on your HA, okay? So if HA, we have, for example, mu more than 2, for example, for HA, it means that your rejection area should be defined by more than. We are talking about such a case. If it is less than, then this case. If we are talking about not equal case, then we are talking about two-sided case. Okay, so we can also generalize it for t-test as well. There's no difference. So in the third step, we do the same. But what's the difference between z-test and t-test then? The difference is that here you are calculating Z alpha using normal standard distribution table. But if you are running t-test, then you should be able to find T alpha using T distribution, and you should take a look at the table of that and find it. For example, for 5%, for 95%, then you should be able to do that. So whenever this is right sided, then we are talking about the 95% case. And when I change the value of alpha, then we are talking about, for example, let's say 98%, then alpha is 2%. We should be careful about such things. We are going to practice together, but you guys should be able to even practice more with this topic because this can be complicated. For statisticians, we have a book just for hypothesis testing, and for the whole semester we talk about it. But for you guys, you should reach it very fast. Of course, we don't go through complicated cases, but those cases that I've collected for you, at least you should be able to run them. Okay, So we have another term which is important here, but before going through that, let me talk about this rejection and acceptance area. So let's say we find Z alpha based on the value of alpha. At the same time, you find your Z0, for example. So in this case, if it is one-sided, and here we can call it right tail one. In case of right tail, if Z0, you compare it with Z alpha. If it falls inside this area, then you accept H0 with, for example, 1 minus alpha confidence level. If it is 95% confidence, then okay, we can say we accept H0 with 95% confidence. And if Z0 is more than Z alpha here, then you should reject H0 by 95% confidence. So usually for students, it's confusing when you don't take a look at the graph. That when, for example, I consider Z0 less than Z alpha as rejected case, and when, for example, vice versa, and for example, for two-sided, it can be even more complicated. So I suggest you guys to draw the graph because it avoids any mistakes. So instead of formulating for you guys about less than, greater, and so on, you know already how to calculate Z alpha, Z0. And if you consider this part, which is very important, that you are drawing this graph based on hypothesis, alternative hypothesis, then everything is very easy. But if you want to formulate everything, then memorize them. It will be so hard to memorize them all. Now, in case of two-sided case, then when you calculate Z0, if it falls between these two regions, you see there are Z alpha over 2 minus Z alpha over 2. So you should calculate two Z alphas actually. So one of them is related to half of it on the left side, half of it on the right side. So if Z0 happens to be between them, for example, Z0 between minus Z alpha over 2 less than Z alpha over 2, then in this case, you can accept it. To be more accurate, I usually prefer to use Z minus alpha over 2 for each side instead of alpha over 2 inside the formula, and I will show you in the tutorial. Why is that? Because when you do that, then this value would be negative, this would be positive, then of course it's better to show the direction differently. See? That's why I prefer to use 1 minus alpha over 2, which I will show you in the tutorial. Okay, another term which is important is p-value. For p-value is related to alpha directly. For the previous slide, we are trying to compare Z0 with Z alpha. Or if it is a t-test, T0 to T alpha. The only difference is that for the values, you should check it in the normal distribution here for T distribution. Okay, so what is p-value? For p-value, I try to calculate it, which is a probability. So for the previous one, these are everything happens on the x-axis, okay? So we are checking everything by these dots, as you can see, Z0, Z alpha, and so on. But when I talk about p-value, we are talking about the probability. It means that we have a, for example, normal distribution or t-student distribution. Then you can find the probability like this, area under the curve. And then you compare it with alpha. Okay, based on that, you can reject or accept your null hypothesis. So what should I do here? In this case, I should find my test statistic first, Z0, okay? And based on that, I should find my p-value. So again, it's important to take a look at your HA. So what's the direction of HA? Is it not equal? If it is a not equal case, then we are talking about this one. If it is more than, then we are talking about this part. If less than, you should check it on the left tail Z or T test. Okay, so now we are talking about, let's say, for example, this is the case and my H0 is something like mu less than 2. Then we have less than value. So when you find Z score based on for your test statistic, then based on this test statistic, you should be able to find this region. Okay, so I know, for example, my Z0 is this value, for example. Then I'm looking for this area and I call it p-value. So you see, p-value depends on Z0. So what I'm doing here, I'm finding this probability. Okay, be careful about this. Z less than Z0. How did I understand that I should use less than? Because of this direction. Okay, if I was talking about this, then for finding your for example a p-value for this one, then you should use this probability. You see, this is very important. So these directions depends on direction of your alternative hypothesis. But what if this is a two-sided case? For two-sided case, it's just good enough to calculate one of them. Doesn't matter left side or right side. Then you should multiply it by 2, because if we are talking about Z0, we are looking for this area. So if you just cover for Z0 here, it means that then you should multiply it by 2. That's why it will cover two sides. So how to reject or accept based on p-value, which is a little different from the previous one. In the previous one, you just compare your Z0 with Z alpha based on your graph, and you understand whether it falls inside the rejection area or not based on the x-axis, right? Not necessarily areas. But for this one, whenever p-value, whatever you calculate here, here, or here, these three cases can happen to find your p-value. Or instead of Z0, you can have, for example, T0. Instead of Z, you can have T, which is other condition. So in order to be able to finally conclude your test, you should consider whether your p-value is less than alpha or not. Let's say in case when this is exactly equal, we reject the null hypothesis too. So whenever this is the case, whether you multiply it by 2 or just one-sided, in any case, the final answer is the p-value. When this is less than alpha, then reject your null hypothesis. Rejecting null hypothesis, it means that you accept your alternative hypothesis. Okay, so this is always this case. This is always this formula. P-value less than alpha, then reject H0. So when we talk about normal distribution or T distribution, that's the way we can reject or accept H0 using p-value. This is another way to test. So again, I remind you guys, whenever we are talking about rejection area or acceptance area, take a look at your alternative hypothesis. So when this is less than, we are talking about left side. When this is more than, we are talking about the right side. When this is not equal, we talk about two-sided case. And that's exactly the reason I consider not equal case for HA, not for example, this case. Let me show you. M actually here stands for median. Usually we are trying to solve questions for mu, mean of population, but anyway. So you see here, I consider equality case for H0, not equal case for 30. At the beginning of the lecture, I promised you to explain why. And that's the reason, because my rejection area is the case for not equal to these cases. It means that not happening in the equal region, because if it happens in the acceptance area, then we accept that M is actually 30. Okay, so that's exactly the reason. And as I always suggest, construct your graph based on HA, because based on the direction of that, you can easily find the rejection area and non-rejection area, which we can also call acceptance area. So there are basically two ways. As you can see, the third way is to use confidence interval, which I will talk about it in the tutorial. So one thing very quickly I mentioned before we finish the session for today is to be careful about what is p-value, what is test statistic. When I ask you to try to run a test, hypothesis test using test statistic, then you find Z0, compare it with Z alpha. So let's say here we have Z alpha. If Z0 happens to be here, you reject your null hypothesis. If it is here, then you accept it. And you should always mention it at what level, and based on alpha, you can define it. But when we talk about p-value, everything should be happening in terms of probability. So let's say if it happens to be here, then obviously p-value is more than alpha. That's why we accept null hypothesis. Okay, guys, I hope this session was useful for you. It is natural if you feel that this is complicated, because you should go through this session again and again. It rarely happens that at once you understood everything perfectly. That's why please go through this session more than once, of course, for many times. And then go through the tutorial. Unfortunately, we just cover maybe 3 examples, one for each type of test, just to show you how it's done. But there are so many cases that, as I mentioned, there is a book for that, and we should teach it in one course, one complete course. That's why after going through the tutorial, please go through the book, examples of the book, not necessarily the ones with the solutions, because the book explains it differently and it's not acceptable for the final exam. That's why please just go through the questions. And if you have questions and you don't know how to solve those questions, because after tutorial, it should make sense and it should be easy, because I already mentioned about all possible cases in this lecture. So even after that, it's not obvious for you, then please let me know in the office hours or using email. You can ask me your questions. Okay, guys, see you.